For lesson 4 of our atomic theory and bonding unit, we're going to be talking about electron configurations and how you determine them with the periodic table as well as how you write them. So first off, the electron configuration are the ways in which electrons are arranged around the nucleus of the atom in the ground state. Now this comes from the periodic table is the easiest way to figure it out, okay? It also comes from those diagrams we wrote yesterday, so if you look back at those diagrams, the numbers we're going to be using are the quantum numbers that labeled the orbitals like we were using yesterday, so things like 1s, 2s, 2p, and so forth, okay? So, determine the configuration of any element. You want to use these steps. So first, the periodic table, the number of the period on the periodic table shows the shell, which is the principal quantum number. For the d orbitals, you just have to remember to subtract 1. The block shows the type of orbital, okay, which this refers to the orbital quantum number we talked about. You want to label these on the periodic table. I'll show you how to label them in a minute here, and record the configuration in the following format. So you'll do principal, orbital, and then a subscript. Now, this is just like we were doing yesterday, again, if you think back to the last lesson. So 1s, something like that, 1s, but then these numbers change with 1 and 2. All right, so looking at the periodic table and how you should label it. So if you look at your periodic table, you want to draw a couple different blocks on here so that you've got some labels that you can come back to when we do these configurations. So the first two over here, first two, I should say, columns, labeled as the S, with the exception of helium. Helium needs to be pretended over here. Okay, helium is an S as well. You can label that so you find yourself. Everything in the middle here, so the transition metals, you want to label as the D. And you can remind yourself the number -1. Okay, and then we'll come back to that in a minute. But then over here, from boron down to the noble gases, not helium, okay, would be your P block. Now your F block is technically down here. The lanthanides and the actinides, but we're not really going to use them, okay? All right, so looking at these guys, you can figure out how to number them if you think about the column or the period numbers going down. So 1, 2, 3, 4, 5, 6, 7. So like this is the 1s1. Helium would be 1s2. And that's all in the first row. Then 2s1 is lithium, 2s2 is beryllium. Then 2p1 is boron. 2p2 is carbon, 2p3 is nitrogen, 2p4 is oxygen, 2p5 is fluorine, 2p6 is neon, and so forth. The only thing that it changes down here is when you do get to this fourth period where you have the D, this is 4s1, this is 4s2. But then this is 3, it's the number -1, so 4 minus 1. So 3d1, 3d2, 3d3, 3d4, 3d5, 3d6. So this would be 4d1, 5d1 in theory, and so forth. Okay? All right, so we're going to practice writing these guys out. So if you think about fluorine here, okay, so fluorine would be right here. Get my pen back here. So fluorine's here. So in order to get here, you'd have the 1s1, 1s2 for helium. Again, we drew that over here. 2s1, 2s2. Then 2p1, 2p2, 2p3, and so forth. Okay, so it ends at 2p5. You have to start at the top and go everywhere down to it. So to write that out, we'd have 2 in the 1s, so 1s2. 2 in the 2s, so 2s2. And then 5 in the 2p, so 2p5. So as you look at this example here, you'll see we got 1s2, 2s2, 2p5. And you'll see they get exponentially longer as you go down. So something like Sb, which is antimony, which has the atomic number 51, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p3. You see they get very long. But again, all of these numbers come from here. Okay, so like if we were looking at yesterday when we looked at fluorine, fluorine has 9 as the atomic number. So yesterday what we were doing is filling them in like this. So this would be 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what you'll see is we have 2 in the 1s, which is right here. Then we've got 2 in the 2s. And then in the 2p, we have 5 arrows. And that's what's written here. Okay, so just kind of writing out what we did yesterday in a little bit different way. All right, so there's plenty more that you can go ahead and practice here. Okay, but you're probably wondering, is there a shortcut to do this? Because they get pretty long. If you look back at antimony there. So yes, there is. It's the noble gas core method. Okay. So what you do is you find the noble gas in the row above, and then you write the remaining configuration. Okay. So looking at an example here. So we've got copper. So I'm going to flip back to this periodic table I have here. We're going to find copper. So we find copper. Copper's right here. Okay. So to use the shortcut way, you move up a row and go all the way over to the noble gas in that row. So in this case, it'd be argon. You're going to write argon in brackets and write everything that's left. So argon in brackets means we're already here. So then we would have 4s2, 3d count over 9. Okay. We write this out. We've got argon in brackets. 4s2, 3d 9. Okay. So then what you're going to do is you're going to keep practicing these kinds of things so you can see them as well. So we'll try one more together here just so you're on the same page. All right, so looking at, we'll just pick calcium. Sounds a little different. So calcium, I look back at the periodic table, I find calcium. Calcium's right here. Calcium's right here, okay? So I go up and over, turns out it's argon again, and then we just have 4s2. Yeah. Okay. Now, what if I already give you a noble gas like argon here? If I do, that's really easy. You just put it in brackets and you're done. Okay. Now, what if it's an ion? Okay, so this has a -1 here, just hard to see. Okay. So fluorine, -1. If it's a negative, write yourself a little cheat sheet here. If it's a negative, you want to move right that many places. If it's positive, you move left. Okay. So fluorine is -1. So we're going to move one place to the right. So fluorine's right here. We move one to the right. We're at neon. So since we ended up with a noble gas here, I just need to write that in parentheses and I'm good to go. So neon, done. So let's try a positive one here. Okay, so let's do sodium +1. All right, so I go back to the periodic table, find sodium. Sodium's right here. I move left one. That means I wrap back around. I end up at neon again. So I would just write neon in brackets, and I'm good to go with that as well. Okay, so there's some additional examples there that you can give a try. Okay, but try these out, see if they're starting to make sense to you.